We will be looking at a new feature which has been added in Houdini version 20. This feature is called Apex and primarily relates to animation. This feature is currently in beta. It's actually pretty rough at the moment, and there's a lot that still needs to be updated in it. There are currently a lot of limitations to Apex, especially when compared to certain other features which have come out in beta recently. It is, however, very powerful, and we're going to be taking a look at how it works. But since this is very early and there are a lot of limitations, there may still be quite a few changes between now and the production version. Currently, Apex is primarily aimed at rigging, and we'll take a look at the basic setup for that. But before we do that, we'll need to take a look at why Apex is being created. So recently, Houdini added Kinefx as a rigging system, which is a geometry-based rigging system. Kinefx moved geometry out of the object level and into the SOPs network. Previously, there was a bone-based rigging system, where the rig was built and manipulated at the object level, and most of the rig's deformation logic was separated from the rig and occurred in SOPs. This follows a trend within the design of Houdini, where features which were previously separated are now all being implemented in SOPs, which creates a more unified and straightforward interface, and also unifies the functionality. As a rigging system, Kinefx is actually extremely powerful, and you can pretty much do whatever you want to with it. However, it has one major issue. To start discussing this, we'll look at a very basic setup for Kinefx. This will have two main geometry components, the first of which will be a mesh, and this is the mesh that we want to deform. We then have a skeleton. In this case, the skeleton is performing two roles. It's performing the role of a deformer, which is causing the geometry to deform, which is what most people would consider to be the skeleton itself. It's then also providing a source of information for controls, and this default information will give us an FK hierarchy. This is a choice which we do have with Kinefx. We can generate the controls off the geometry live, or we can create specific geometry to generate the controls. The rig will then have a control setup, and to manipulate the rig, we'll use a rig pose node. As stated previously, we're just rigging the skeleton here. The skeleton or controls are essentially defined as joints, and we can transform those joints within this node. Next, I'll add weights to the rigs. This process will not usually affect the performance of the rig, as this can rarely be done separately and can be performed as part of importing the geometry, but it is necessary to discuss the workflow. Finally, we'll have a bone deform node, and this will display the deformation of the geometry. So there is one major issue within this system, and that issue revolves around the rig pose node. Now essentially, the rig pose node will be an individual node, and to create the rig, we'll need to separate the rig into solvers and rig pose nodes, and we'll have multiple of these, and there will be a lot of rig pose nodes. Also, since in rigging order of execution matters, we will need to have multiple rig pose nodes in order to maintain order of execution, as each of the rig pose nodes is calculated individually in order. This will lead to problems as the rig gets larger. Each of these nodes will need to be evaluated every single time we update the rig. They will all be evaluated individually, and the more of them there are, the more evaluation time we will have. This means that the more complex the rig, the more unresponsive it will become. So this is a basic setup. We can take a look at something a little bit more complex. This is not a particularly complex setup, but it is more complex than the basic setup. We have the same geometry, we have the tube and the rig. I've then separated these, so now I have a control network and a skeleton network which have different geometry. We now have two separate rotations at the center of this skeleton. We have a pose node for the original rig which can be rotated. We then have a second control for this, and this joint can be rotated independently of the first joint. These feed into a basic solver. The solver is just blending the transforms between these points. We are then calculating the weights, and we're doing the deformation. So there's nothing complex here. We can rotate our joints, and then we can blend between those rotations. Here, we have potentially tripled the evaluation time for this network. Every time we run the network, we'll need to calculate the first pose node, the second pose node, and then we'll need to calculate the solver. With the pose node, we are not just getting the data from this node. The main usage of this node is actually the calculation of a viewer state. The viewer state here will be called rig pose, which is essentially the same as the node name. We can view this viewer state by editing it. We'll see that this is a Python script. Python is not the fastest programming language. Although this is not technically a problem, it is still something which will add up. Technically, the script will not run with every single post node, and we'll examine that later, but the script will still have to find every single post node within the network, and we'll need to have it evaluated for every single post node. With rigging, order of execution is important, and certain things cannot be achieved unless we have multiple post nodes. For example, here we separate out parts of the hierarchy, so we can operate on the hierarchy separately. This is not a very practical example, but it does illustrate the problem. So the moment you get beyond very basic rigging, you are going to end up with a lot of extra post nodes, and this will cause your rigs to slow down more. This is of course not how the final rig will look. For example, a final rig could just be a single HDA, and this would essentially have the parameters exposed, so we can manipulate the parameters and the transforms in the interface, and we'd never actually enter the rig. With this we can manipulate the rig, and we can manipulate all of our points simultaneously. To see how this is done, we can enter the type properties, and under the node tab we can see that we have a default state here. This is essentially using the same viewer state as the rig post nodes. This viewer state is referencing every single rig post node within the scene, and it's updating the final state based off all of them. They are, however, all still being evaluated individually, so we still have to evaluate every single rig post node, and we have to evaluate every single solver, even if we can cut down on the evaluation of individual viewer states. So this works, and it's an extremely powerful rigging system, but it can become reasonably slow when the rigs become large. And the reason it is slow is because of how we need to traverse the network in order to evaluate the rig. So the aim of Apex is to remove the need to evaluate every single node. Instead of evaluating nodes, we create a logic graph, and this graph is evaluated at the end of the network, and the entire evaluation of the network only happens once. So instead of having multiple nodes, we generate a single graph and we evaluate this graph. This graph is actually geometry, so we're generating a mesh. This geometry is storing both the network and all the information within the network, and this geometry will be evaluated at the end of the network once. So instead of updating multiple viewer states or evaluating a viewer state over multiple nodes, we'll have a single viewer state which will run once. There are a couple of Apex viewer states here which are not actually relevant to this, and are not what we're actually using. The viewer state here which you're looking for is actually the animate viewer state. It is implied that Apex will be used to generate networks from Kinefx nodes in the future. That is not part of the current system, and I will not assume that that will happen in the future. So we'll be looking at Apex as an individual entity for now. We'll now set up an extremely basic Apex network, and this is primarily to look at the structure of the network. The Apex network will also be a geometry network, so I'll need a geometry node. Once again, the major difference is we're not manipulating geometry here. Instead, we're creating geometry that is a store of information. The main node for Apex, and the node that we'll do most of our work in, is called the Apex Edit Graph. To work with this node, I'm going to split the viewport, and I'll open my parameters here. This is because I want to work with my parameters, and the current implementation of Apex requires its own network view, which is separate from the main network view. This is useful as it allows multiple network views without pinning tabs, but it does feel a little bit clunky and disjointed, as one of the places where Apex could use a little bit more polish. This viewport does lack some basic functionality. For example, at launch, copy and paste did not work for me. The newer production builds do allow for this, so your experience may vary here depending on what version you're using, and if you're locked to a very early version of Houdini 20, then you may lack quite a lot of functionality. But we can also expect a number of changes and improvements here, which will occur in the daily builds. Personally, I would prefer if this network worked more like a VOP network. Essentially, I'd like for this node to function as a VOP node, even if it's not a VOP node under the hood. So there is a little bit of inconsistency here in terms of workflow, but I expect that to improve. While I prefer to have the single network view, having network views separated like this does make our workflow slightly easier, but as I said, it needs more polish. One of the things which I do not like, which I do hope is a developmental thing, as it's the kind of thing which you add when testing things, but it's probably not a good idea, is the fact that we have a self-destruct button on the edit mesh node. Generally, a button which can remove all your functionality instantly is not a good idea. This kind of functionality should be on one of the submenus under the network, although if we want to clear a network, we should actually just select the nodes and delete them. This is a button which would be better if it was removed in the future. There's always a possibility when something can break that it will. We then have a number of utility scripts, and these can be useful for building out your network more quickly, and these are mainly focused at building a manual network. We'll take a look at what some of these do at a later stage. So the edit node is our main node, and there are not that many nodes which it will connect to, but the main node that this will deal with is the Scene Animate node. The edit node will create a graph, the Scene Animate node will analyze that graph, will then generate and animate the rig within this Animate node. So the edit graph is the start of our network, and the Animate node is our end. This Animate node, however, does not directly create this graph. Instead, it takes packed geometry, which contains this graph. We'll generate this with a node which is called pack folder. Essentially, this is going to create some packed geometry. This packed geometry will be merged in a format which will specifically contain our rig. So we can now take a look at our graph. There are two nodes that we will almost always input into this graph. The first will be a subnetwork input. The second will be the subnetwork output. Out of the gate, I'll always change these to be palms and outputs, and I'll make sure that all the underscores are removed. These are default values which are used by Houdini, and your graphs may not automatically work if you do not change these. A number of the examples which Houdini provides do not work properly if these names are not changed. Although that's not necessarily important, but that is something which we'll cover later. We can then have some functionality to connect between these nodes. I'll start with the basic add node. I'll then turn off our ghosted objects within the viewport, and we should be able to see the start of our geometry within the viewport. There should be a couple of points here which are representing the nodes which we have just added. When we move our nodes, we should see that these points move as well, and these points are actually the geometry which is stored within this network. If we connect the nodes, we'll have lines appear that connect our points, and the lines will show the connections within the network. When we move the nodes now, the movement of the geometry will become more obvious. To save out this network, we can use a file node, and we can export this as a BGO file. We could then import the BGO file directly and use that BGO file to drive our graph instead. So the geometry from the graph will run in exactly the same way as the graph made in the edit graph node. So essentially, when I say this is geometry, it is literally geometry. Basically, we are generating geometry with attributes on, and that's giving us all the functionality for our nodes. So we have different attributes in different places. We have detail attributes which will contain dictionaries, which will store certain amounts of information. As you see here, we'll have a palms attribute. This is a default dictionary for storing parameter information. There'll be a callback attribute on the points, and this will actually specify the type of node we add in. And when we move our nodes in the network, we'll see that it actually changes our point position over here. So that's the basic setup for the node. We can now add some functionality. In this case, I'll remove the add node. We'll now add the main node which we need to interact with our rigging system. I have added a rigging system, so we'll see how this actually translates. But this rigging interface will need nodes which it interfaces with. Currently, this is mainly done with a single node, and this is actually probably the most important node to add to this network. This node is called the Transform Object node. All of our controls within the final Animate node will be referencing Transform Object nodes. I'm going to connect a parameter from our input node to this Transform Object node. Specifically, there is a T parameter within this node. This is a green color and is actually representing a vector for translation. When I connect this, the output for the input node should get the same name as the parameter that it's been linked to. We also have other parameters which we can add. For example, we have our rotation and we have our scale. One thing to note is that by default, all of the parameters that we add to this network will always be zeroed out by default. So generally, we will need to update the values for these parameters. This is something which is pretty horrible to set up manually. It's far better to script, but we're not going to look at that yet. Compared to Kinefx, Apex is far more script heavy in how you set up things, but it does have the advantage in that you can store all the functionality within a single network, and all the approaches which we take will be to build this single network. We can now evaluate this network in the Animate node. The Animate node also has a number of self-destruct buttons. However, these relate to this node being a cached instance, so they are more relevant to the actual functionality of the node, as we'll need to reset it every single time we update our network. The access to the animation information is still relatively limited here, and is something which will need to be improved. I can press enter in the viewport to activate the view state, and we'll see that nothing shows up. We also have a selection set, and this lists all the items within our scene, and here we have nothing that can be manipulated. So we'll need to do more than this in order to create the rig. The issue here comes from how we've packed our geometry. We can edit an existing edit graph through the first input of this node, but our edit graph that is going to be displayed must initially be added through the second input, as this graph will need to have a name and a type, and we'll need to store this when we pack the graph. This is done to geometry which comes in through the second input, and so we'll change our connection. Here we'll have a name. The default name for this will be base, and this will have a capital B. This is the name used in most of the default scripts, as well as in the default automatic rigging nodes. After this we'll have a type, and for us to be able to manipulate this, we'll need to set this type to be rig. For basic rig, we'll generally have a shape for the mesh, and a skeleton for the rig, as well as a rig for the controls for the rig. We will not deal with the other options yet. At the moment, this will be a rig. If I select the Animate node now, we'll see that we have some options. The first of these will have the name base, which is the name for our geometry. And under this, it will list our transform object node. When we select this, we'll have a gizmo for this object. This gizmo will give us the ability to scale, rotate, and transform this object. And this is because I've connected all three of these inputs. If I return to my graph, I can disconnect two of these so that I only have a translation. I'll rename the transform object to test point. And if I go to the animation node, we'll see that we've got no changes. This is where the reset all comes in. Just be warned, you'll lose any animation which you have when you use this button. Our control is now called test point, and when I select it, I only get a translation control. The position has been reset to 0, as everything for this control is currently zeroed out. So this is the basic graph and the basic manipulation pipeline. There are then a number of nodes which are based off either building graphs or adding information to graphs. We will not go through any of them in much depth now, but we will take a look at a couple of the more important ones. The first of these will be the auto rigger. This is a node which will build preset network parts, like FK controls, spines, and IK controls. Essentially, there's a preset component dropdown, and all of these are presets which can be made. All of these are graphs which are actually being loaded as geometry, although the graphs themselves are not actually what is being used. The graphs are actually technically scripts which will build the final graph, so they're building a graph rather than being used as the graphs themselves. If we go to the side and look at the pink nodes, we'll see that there's a file node over here. This file node is actually having its reference set to a piece of geometry, and that geometry is the graph which we are busy loading. If we open the file browser, we can see we're in the Apex geometry folder. The geometry within this folder are all graphs. So for example, if we set this node to use the spine, we would reference this spine component geometry. If I open the parameters for this node once again, we'll see the reference for the component file, and this component file will build our network. In this case, the files are all standard BGO files, and they are uncompressed files, which means they should be ASCII files, and we should be able to open the files and read them. The next node that we'll look at is the Apex Configure Controls node. This will need to have the packed geometry attached to the first input. This node has a purple input. This input will match the purple input for the auto-rigger node. Generally, this means that the input will require packed geometry. With this node, we'll start by referencing our geometry. By default, this will be base.rig. So if I change the name in the packed geometry, we'll need to change this. I'll change the name to rig.rig. Once I've done this, I'll need to change the rig source, and we can change this to rig.rig. This is how this node references our network. We can then add shapes. If our graph is working correctly, we should be able to configure the shape, and this should show up in our dropdown. Here I only have one control, and that is my test point. I can then add a shape override, and in this case I'll use a cross. We can test this, but it will not currently work as we need to update our network. But when we reset the network, we should have a cross at the center of the world, and we can use this to now select our control. And we can, of course, customize the controls more, so we can, for example, add color. So this gives us our basic setup. We have our graph. We then pack the graph. We then have operations which we can perform on the packed geometry. In this case, I'm adding controls. And then at the end of the graph, we can animate the network. So essentially, we're now using our edit graph node to create the controls within our animate node. We can now look at the animate node. I'll open the type properties for this node, and we'll go to the node tab. And here we'll see that this node is using the animate viewer state. If we look through our viewer states, you'll see that this is highlighted in green because it's currently in use. We can always see the functionality by looking at the viewer state. I'll do this by bringing up the context menu and I'll edit it. And you can go through this if you want to get an idea of how the animation setup is working. And this script should essentially be running over our final graph. Once again, within Kinefx, we're going to evaluate all of our nodes, and these will be evaluated in order every single time we execute the network. So here we would evaluate this pose node, and this pose node, and this solver. And all of these would be evaluated separately. And once again, that's the primary difference between this setup and the Apex setup. This approach does make Apex slightly less flexible. It's also more technical to work with, but it will run faster, and it will also make it easier to store the logic of our rig. So that's the basics of the Apex setup. So next we'll need to look at how to examine information in Apex, as well as add functionality.